Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya. Greetings to all of us. The first of all, I would like to thank you, our lecturer, Mr. Alfredman, for giving us a little opportunity to explain one of the materials about management information system for this occasion. But before we get started, I want to introduce my fellow group members. The first one is Hafiz Pratama Putra, and then there is M. Zakmanel Haris, and then Fi Alwadis, and the last one is Nabil Azza. In this occasion, we would like to explain about information system development that we already been researching before. Next slide, please. There is four content in our. First one is system development lifecycle, and then rapid application development, and the third one agile methodologies, and the last one is programming languages. And the first content will be explained by Nabil Azza. To Nabil, time is yours.
Okay, the first content is System Development Lifecycle. The System Development Lifecycle, or CDLC, was first developed in the 1960 to manage the large software project associated with the corporate system running on mainframes. This approach to software development is very structured and risk-averse, designed to manage large projects that include multiple programs and systems that have a large impact on the organization. It requires a clear, upfront understanding of what the software is supposed to do and is not amenable to design change. This approach is roughly similar to an assembly line process, where it is clear to all stakeholders what the end product should do and the major changes are difficult and costly to implement. Various definitions of CDLC methodology exist, but must contain the following phases. The first one is preliminary analysis. A request from a replacement or new system is the first review. The review includes questions such as, what is the problem to be solved? Is the creating solution possible? What alternative exists? What is currently being done about it? Is this project a good fit for our organization? After addressing this question, a feasibility study is launched. The feasibility study includes an analysis of the technical feasibility, the economic feasibility, or affordability, and legal feasibility. This step is important in determining if the project should be initiated and may be done by someone with the title of requirement analyst or business analyst. Next slide. The second is system analyst. In this space, one or more system analysts work with the different stakeholder group to determine the specific requirement for a new system. No programming is done in this step. Instead, procedures are documented. Key players or users are interviewed, and the data requirements are developed in the order to get an overall impression of exactly what the system is supposed to do. The result of this phase is a system requirement document and may be done by someone with the title of the system analyst. The third one is system design. In this phase, a designer takes the system requirement document created in the previous phase and develop the specific technical detail required for the system. It is in this phase that the business requirements are translated into specific technical requirements. The design for the user interface, database, data input, and outputs and reporting are developed here. The result of this phase is a system design document. This document will have everything a programmer needs to actually create the system and may be done by someone with a title of system analyst, developer, or system architect based on the scale of the project. Next step, next slide. Next one is programming. The code finally gets written in the programming phase. Using the system design document as a guide, programmers develop the software. The result of this phase is an initial working program that meets the requirements specified in the system analysis phase, and the design developed in the system design phase. These tasks are done by person with a title such as developer, software engineer, programmer, or coder. The next one is testing. In the testing phase, the software program developed in the programming phase is put through a series of structured tests. The first is a unit test, which evaluates individual part of the code for error or bugs. This is followed by a system test in which different components of system are tested to ensure they work together properly. Finally, the user acceptance test allows those that will be using the software to test the system to ensure that it meets their standard. Any bugs, error, or problem found during the test are resolved, and then the software is tested again. These tasks are done by person with titles such as tester, testing analyst, or quality assurance. Okay, back to the moderator.
Okay, thank you for Nabil Azza for explaining the what for the explanation. And then the next slide will be explained by Hafiz Pratama Putra. Hafiz, time is yours.
Okay, the next is implementation. Once the new system is developed and tested, it has to be implemented in the organization. This phase includes training the users, providing documentation and data conversation from the previous system to the new system. Implementation can take many forms, depending on the type of system, the number and type of users, and how urgent it is that the system become operational. The last is maintenance. This final phase takes place once the implementation phase is complete. In the maintenance phase, the system has a structured support process in place. Report bugs are fixed and requests for new features are evaluated and implemented. Also, system update and backups of the software are made for each new version of the program. Since maintenance is normally an operating expense, while much of development is a capital expense, funds normally come out of different budgets or cost centers. The next is rapid application development. Rapid application development focus on quickly building a working model of the software, getting feedback from users, and then using that feedback to update the working model. After several iterations of development, final version is developed and implemented. The RED methodology consists of 4 phases. The first is requirement planning. This phase is similar to the preliminary analysis, system analysis, and design phase of the SDLC. In this phase, the overall requirement for the system are defined, team is identified, and feasibility is determined. The second is user design. In the user design phase, representative of the users work with the system analysts, designers, and programmers to interactively create the design of the system. Sometimes, a joint application development or JET session is used to facilitate working with all of these various stakeholders. JET session brings all of the stakeholders for a structured discussion about the design of the system. Application developers also participate and observe, trying to understand. Application developers also participate and observe. And the next is construction. In the construction phase, the application developers working with the users build the next version of the system through an interactive process. Change can be made as developers work on the program. This step is executed in parallel with the user design step in an iterative fashion, making modification until an acceptable version of the product is developed. The last is cutover. Cutover involves switching from the old system to the new software. Timing of the cutover phase is crucial and is usually done when there is low activity. For example, IT systems in higher education undergo many changes and upgrades during the summer or between fall semester and spring semester. Approach to the migration from the old to the new system vary between organizations. Some prefer to simply start the new software and terminate use of the old software. Others choose to use an incremental cutover, bringing one part online at a time. A cutover to a new accounting system may be done one module at a time, such as general ledger first, then payroll, followed by account receivable, etc. Until all modules have been implemented, a third approach is to run both the old and new system in parallel. Comparing results daily to confirm the new system is accurate and dependable. Okay, thank you. Back to moderator.
Thank you, Hafiz, for the explanation about rapid application development and a little bit about systems development life cycle. For the next content, I will explain about the Agile methodologies. Next slide, please. Okay, Agile development methodologies is a method that is often used by companies in their software development process. The main focus of Agile development is to ensure rapid and iterative delivery of business value with strong collaboration between development teams and stakeholders. For example, there is a company that is developing an application, then suddenly a pandemic arises that require us to meet new needs in society. So we ourselves must also be up to date about the news that's happening and booming. That way the software becomes flexible and more efficient according to market condition and desires. This method certainly has a different function from RAD or a rapid application development, which is more functional to produce prototypes and functional applications quickly, thus allowing direct feedback from users and accelerating the development cycle. Next slide. And then there are four characteristics of agile methodologies. There is the first one is small cross-functional teams that include development team members and users, and then daily status meetings to discuss the current state of the project. The third one is short time frame increments from days to 1 or 2 weeks for each change to be completed. And the last one is working project at the end of each iteration, which demonstrates progress to the stakeholders. So the point is, agile development is a collaborative and iterative approach to software development that focuses on delivering value quickly and adapting to changing requirements. By embracing flexibility, continuous feedback, and close collaboration, agile development empowers teams to respond effectively to customer needs and market dynamics. It promotes transparency, customer satisfaction, and continuous improvement, resulting in high-quality software solutions. With a strong emphasis on teamwork and communication, agile development enables organizations to deliver successful projects in a fast-paced and evolving environment. Next slide, please. And the last content is programming languages. So what is actually programming languages? Is it a kind of languages that we can use to communicate, or it's have another meaning? So the simple answer for that question is programming languages is a language that used by programmers to give instructions to a computer. More detail, the programming language is formalized set of rules and syntax used to communicate instructions to a computer or computing device. It provides a means for programmers to write code, which is then translated into machine-readable instruction that the computer can execute. Here are some commonly used programming languages such as Python, Java, JavaScript, C++, and etc. And over the past few decades, many different types of programming has been developed. Maybe the next explanation will be explained by M. Zakwan El Haris. Zakwan, time is yours.
Okay, thank you for the moderator. And I will continue what my friend said before. In a generation of programming language, every language were specific to the type of hardware that had to be programmed. Each type of computer hardware had a different low-level programming language. In those early language, very specific instructions had to be entered line by line, a tedious process. First generation language were called machine code because programming was done in the format the machine or computer could read. So programming was done by directly setting actual ones and zeros, or we call the bits, in the program using binary code. Here is an example we can see in this picture below. Okay, next slide. Assembly language is the second generation language and use English like phrase rather than machine code's instruction, making it easier to program. An assembly language program must be run through an assembler, which converts it into machine code. Here is a sample program that adds 1, 2, 3, 4 or 4, 3, 2, 1 using assembly language. We can see it in this picture. The third generation language are not specific to the type of hardware on which they run and are similar to spoken language. Most third generation language must be compiled. The developer writes the program in a form known generically as source code. Then the compiler converts the source code into machine code, producing an executable file. Well, now, third generation language include BASIC, C, Python, and Java. Here is an example we can see right here. Next. The fourth generation languages are a class of programming tools that enable fast application development using intuitive interface and environments. Many times, a fourth generation language has a very specific purpose, such as database interaction or report writing. This tool can be used by those with very little formal training in programming and allow for the quick development of application or functionality. Examples of fourth generation language include like Clipper, Focus, SQL, and SPSS. Why would anyone want to program in lower level language when they require so much more work? The answer is similar to why some prefer to drive manual transmission vehicles instead of automatic transmission one, namely control and efficiency. Lower level language such as assembly language are much more efficient and execute much more quickly. The developer has finer control over the hardware as well. Sometimes a combination of hardware and lower level language is mixed together. To get the best of both worlds, the programmer can create the overall structure and interface using a higher level language, but use a lower language for the part of the program that are used many times. require more precision, or need greater speed. Next. Next, please. Compile versus interpret. Besides identifying a programming language based on its generation, you can also classify it through the distinction of whether it is compiled or interpreted. A computer language is written in a human-readable form. In a compiled language, the program code is translated into a machine-readable form, called an executable that can be run on the hardware. Some well-known compiled language include C, C++, and COBOL. Interpret language require a runtime program to be installed in order to execute. Each time the user wants to run the software, the runtime program must interpret the program code line by line, then run it. Interpreted language are generally easier to work with, but also are slower and require more system resource. Example of popular interpreted language include BASIC, PHP, Perl, and Python. The web language of HTML and JavaScript are also considered interpreted because they require a browser in order to run. The Java programming language is an interesting exception to this classification, as it's actually a hybrid of the two. A program written in Java partially compiled to create a program that can be understood by the Java Virtual Machine, or we call JVM. Each type of operating system has its own JVM, which must be installed before any program can be executed. The JVM approach allows a single Java program to run on many different types of operating systems. I will be back again. Thank you.
Okay, programming tools. To write a program, you need little more than a text editor and a good idea. However, to be productive, you must be able to check the syntax of the code and, in some case, compile the code. To be more efficient at programming, additional tools such as an integrated development environment or IDE or computer-aided software engineering or CASE tool can be used. So first we gonna talk about integrated development environment or IDE. For most programming languages, an integrated development environment can be used to develop the program. An IDE provides a variety of tools for the programmer and usually includes first editor. An editor is used for writing the programs. Commands are automatically color-coded by the IDE to identify command types. For example, a programming command might appear in green and programming statement might appear in black. Next one is help system. Help system gives detailed documentation regarding the programming language. Next one is compiler or interpreter. The compiler or interpreter converts the programmer's source code into machine's language so it can be executed on the computer. Next one is debugging tool. Debugging assists the developer in locating error and finding solution. So when the user of the software finds an error, so they can report it on debugging tools. So the developer can know what and where the error is so they can fix it. The last one is check-in or check-out mechanism. These tools allows team of programmers to work simultaneously on a program without overwriting another programmer's code. Next slide. Case tools. While an IDE provides several tools to assist the programmer in writing the program, the code still must be written. Computer-aided software engineering or CASE tools allow a designer to develop software with little or no programming. Instead, the CASE tool writes the code for the designer. CASE tools come in many varieties. Their goals is to generate quality code based on input created by the designer. Will versus buy. When an organization decides that a new program needs to be developed, they must determine if it makes more sense to build it themselves or to purchase it from an outside company. This is the build versus buy decision. There are many advantages to purchasing software from an outside company. The first one is it is generally less expensive to purchase software than to build it. Second, when software is purchased, it is available much more quickly than if the package is built in-house. Software can take months or years to build. A purchase package can be up and running within a few days. Third, a purchase package has already been tested and many of the bugs have already been worked out. It is the role of a system integrator to make various purchase system and the existing system at the organization work together. There are also disadvantages to purchasing software. First, the same software you are using can be used by your competitors. If a company is trying to differentiate itself based on a business process incorporated into purchase software, it will have a hard time doing so if its competitor use the same software. Another disadvantage to purchasing software is the process of customization. If you purchase software from a vendor and then customize it, you will have to manage those customization every time the vendor provides an upgrade. This can become an administrative headache, to say the least. Next slide, please. End user computing, or EUC. In many organizations, application development is not limited to the programmers and analysis in the information technology department, especially in larger organizations. Other departments develop their own department-specific application. The people who build these applications are not necessarily trained in programming or application development, but they tend to be adept with computers. A person who is skilled in a particular program, such as spreadsheet or database package, may be called upon to build smaller application for use by their own department. This phenomenon is referred to as end-user development or end-user computing. End-user computing can have many advantages for an organization. First, it brings the development of applications closer to those who will use them, because IT departments are sometimes backlogged. It also provides a means to have software created more quickly. Many organizations encourage end-user computing to reduce the strain on the IT department. End-user computing does have its disadvantage as well. If departments within an organization are developing their own application, the organization may end up with several applications that perform similar functions, which is inefficient. Since it is a duplication of effort, sometimes these different versions of the same applications ends up providing different results. This bringing confusion when departments interact. And user applications are often developed by someone with little or no formal training in programming. In this case, the software developed can have problems that then have to be resolved by the IT department. Next slide, please. Another point is implementation methodologies. There are several different methodologies an organization can adopt to implement a new system. Four of the most popular are listed below. First one is direct cutover. In the direct cutover implementation methodology, the organization selects a particular date to terminate the use of the old system. On that date, users begin using the new system and the old system is unavailable. Direct cutover has the advantage of being very fast and the least expensive implementation method. However, this method has the most risk. If the new system has an operational problem, or if the users are not properly prepared, it could prove disastrous for the organization. The second one is pilot implementation. In this methodology, a subset of the organization, known as a pilot group, starts using the new system before the rest of the organization. This has small impact on the company and allows the support team to focus on a smaller group of individuals. Also, problem with new software can be contained within the group and then resolve the problem. The third one is parallel operation. Parallel operation allow both the old and new system to be used simultaneously for a limited period of time. This method is the least risky because the old system is still being used while the new system is essentially being tested. However, this is by far the most expensive methodology since work is duplicated and support is needed for both systems in full. And the last one is phase implementation. Phase implementation provides for different functions of the new application to be gradually implemented, with the corresponding function being turned off in the old system. This approach is more conservative as it allows an organization to slowly move from one system to another. Okay, back to Nubodoroto.
Okay, thank you, Kriya Waris, for your explanation about programming languages. And maybe that's all the presentation from us that discuss about the information system development, which is include four important content. And from this presentation, we are hoping that you guys can now understand at least about the information system development itself. And if there are any mistakes, we are deeply apologize. And we also hope that you guys can help us to do the correction of those mistakes. And for that, I close this presentation. Thank you for all of your attention. Wassalamualaikum warahmatullahi wabarakatuh.